last class, remember we talked about Greco-Latin square, right? We have covered all blockings possible, or we know how to analyze multiple independent factors or treatments or blocking nuisance, whatever you want to call, but that is all independent. So far we have never done about interactions, or we have not talked about synergistic effects, which is quite common in biomedical engineering, quite common in pharma, etc. So there is always going to be interactions. Okay. The question is whether linear or non-linear is a different question, okay, but interactions exist, okay, and that is one of the critical things. Sometimes interactions is the most important thing even than the main effects, right. So now we will talk about main effects as well as interaction effects. Sometimes interaction effects will dominate the main effects itself, okay. So that is where we are going to talk about what we call two-way ANOVA, okay. We have learned only one-way ANOVA, okay, meaning one independent or one factor at a time at multiple levels. Now what we are going to do today is do what is called two-way ANOVA, and of course you should think of now where do we end up here, multi-way ANOVA, right, two-way, three-way, and how to include multiple way ANOVA. It is not straightforward, it will pose challenges, okay. So we will at least do three factors, okay, two-way and three-way, and then give you an idea about how to do n-way ANOVA, okay. So this is one way we are talking about. N-way ANOVA is the what I call the highest setting, okay. So we will start learning about two-way, okay. So the reason is we are comfortable doing independent variables, one or multiple independent variables, that we are comfortable. As I told you, multiple independent variables also we know to handle. It is not just one way ANOVA, we can use RCBD, we can use Latin, we can use Greco-Latin squares. So multiple independent with blocking, all of those we know. However, there are influence of several variables operating and they are all combined to influence the performance, okay. Factors combined to influence their performance. So interaction is something that is not cannot be neglected, even if you talk about two factors. So we are talking about two-way ANOVA, so we are simply leading two factors instead of one. Now we are doing two factors. The questions we could ask is how significant is A, effect of A, effect of B, and the third important question is how do they gel when they combine together, effect of AB, right, treatment A and treatment B when I combine, what are the effects, okay, unlike independent. So the first two questions are main effects. We could have simply did an RCBD kind of analysis, okay, but what will not be possible to answer is the third question, okay. The third question is about interaction and it is not going to be possible, right. Even if you do RCBD, you can understand A effect separately, you can understand B effect separately. Like constructing two RCBDs, you can understand one, you can keep A constant, you can keep B constant, you can do all combinations, but never understand the interaction effects. So whatever you have so far studied, even if you do multiple experiments of them, you will not be able to understand the interactions, okay. That is the challenge. So now we have, so what kind of experiments do we do to understand interactions, okay, that is the next question. What kind of experiments should one perform when doing interactions, and that is where we talk about factorial design, right. As I told you, we are getting more into details of how to conduct experiments and how to analyze them to make sense out of it, right. So this is more of 2 weeks back when we made a call, we said we will delve deeper into experimental side because that is something new, right. Machine learning, there are many techniques to handle data, but how to even generate data systematically is what we are learning, okay. So here when we talk about when you want to analyze interactions, right, when you want to get the kind of data which will give you information about interactions, you want to perform what is known as factorial designs, Okay. So, what is a factorial design is simple, I will do at a 2 cross 2 and it will scale up huge when you talk about multiple factors. Okay. So, 2 cross 2 is very simple, 2 factors at 2 levels, that is what I said, people call it as 2 power 2, 2 factors at 2 levels. Okay. So, 2 is the base 2, the people typically write it as like this, 2 power 2, this is factors, this is levels, 2 power 3 is 3 factors at 2 levels. Okay. So, levels is pretty easy, 2 levels is simple because you either have it or you either do not have it, yes or no, binary. Okay, that is what 2 levels is, and typically you can do it at 2 factors, 3 factors, etc. So, here is a simple case where you have A1, A2, B1, B2, B1 presence of B at both the levels of B1 both the levels of A and B2 at both the levels of A. So, you can look at B1, 4 experiments are done. So, B1 at A1 and B1 at A2 level and B2 at A1 level, B2 at A2 level. In this matrix, if you form this matrix, all combinations are made. So, this is kind of called crossed, the design is crossed, meaning you have conducted experiments at all possible combinations. But truly if there are multiple factors, can you do this kind of crossed experiment? If there are 5 factors, how many you should be doing minimum? 2 power 5, right, that becomes 32 experiments, that is only at 2 levels. Now do you want to see only at 2 levels? If you want to do finer details, then you may increase the levels as well, then crossed may not be possible. Okay. There we introduce what is known as confounding, we will see it later. Have you heard of this word called confounding? What does confounding mean? What does confounding mean? Huh? When you are not able to distinguish which factor caused the output, which factor influenced your output precisely, right. Suppose there is always a in cricket or this thing, so who contributed significantly over the other is actually a confounding effect, right. So, when things and you have to perform experiments, enough data to actually distinguish who is the better contributor, etc. You may not even get data many a times. So, what I am saying is if there are 10 levels and 5 factors, how many experiments are you going to do? If you want to fine grain 10 power 5, imagine, soon the experiments will blow up. Okay. So, that is where the challenge is. So, you will invariably end up what is known as confounding, meaning you will not be able to distinguish all factors that influence the output at a fine grained level. So, when doing experiments you have to be careful what you are confounding, right. Probably when you are doing age and gender may be confounded. You are paying attention to age, but you are not paying attention to gender, it is mixed. So, age and gender you are not distinguished, right, or some kind of say let us say disorders or previous history, if you are missing out then they become confounded. So, you have to be very clear what is when experiments, what this experiment can give and what experiment this cannot give. This cannot give us what confounding is. Okay. So, you can simply say this result is confounded for factors A and B, I cannot distinguish factors A and B and I am okay to live with it. Okay. There was one group who were trying to determine whether mouse had the inherent ability to pick up cheese. Okay, whether what is driving factor that led mouse to pick up a cheese. Okay. Now, what kind of experiments will you design? I want to know whether mouse inherently has ability to pick up cheese, whether the nose has the inherent capability to pick up cheese. What kind of experiments will you perform? So, it is not as easy as you think. See how many confoundings you have to for a simple experiment. It is actually not simple experiment. People have conducted it with many confounding factors. Okay. So, this is the level of experiments one have to think about to remove confounding. Okay. So, that is why experimental design is a major. So, good data today is the key, right. So, I do not know how many of you know today everybody knows CNN. Where does it started? Where does the CNN revolution started, do you think? It is not the algorithms which drove today what we are, it is the data. So, everybody know about ImageNet, image data set, image data, call it as ImageNet. That was the starting point of today's CNNs. It is the algorithms are as good as the data itself. You should have rich data to do analysis. So, experiments are much more important today than the analysis itself, because there are so many analysis algorithms out there, but rich data is very important. So, confounding, one has to be very clear when you do experiments what kind of confounding you make. Okay. 2 power 2 is easier, but it will not be the case when you scale up in reality. So, confounding will definitely come into picture. So, this is what we are doing, effect of B at level A1 and effect of B at level A2. When do you say this there is an interaction? When can we say from this table, can I say, when can I say there is an interaction? I have this data, say let us say some numbers are there, I will give you numbers also. Okay, this is 2 power 3, okay, let us take only, let us take this numbers B1, B2, A1, A2. Let us take this number as 5, this is negative 20, 6, negative 80, and then I have another one 5, 7, 6, 8. When can you say interaction is there? You saw the numbers? How do you determine interactions? From the data. Looking at the data, you should be able to say how do you do it? If there is a linear increase, see if I have something like this, do you say interaction is there? You saw this graph, in the graph I make, there are 2 lines already, I draw a third line where this is 1, this is B2, sorry, yeah, this is at B2. Which one has more interactions? There are 2 cases here, A1 to B1 is the same, okay, A1, the blue, let us have the blue the same, okay. The second one, there are 2 options, so this is case 1 and this is 2, you have 2 options, that is A2 B2 is different, A2 B2 is different. Which one has more interactions? What is the interaction between AB in case of A2 B2 being case 2 and in case of interaction in case of A2 B2 for case 3. So, you have 2 cases, case 2 and case 3, okay. Case 1 is A1 B1, okay, case 1 let us call this way, now this is case 1, case 2. Difference between case 1 and case 2 is the A2 B2 point, the A2 B2 point, okay. A1, this is what, A1 B1, okay, and A2 B2, okay. I have 1 and 2, forget this blue line, I have 1 and 2. Look at this, which one has more interactions, whether case 1 has more interactions or case 2 has more interactions. How do you even think about interactions? See, there is a lower level of A1, look at the first this area region, there is a lower level of A1, lower level of B1, higher level of A is at low level. So, this is A is at low level, B is also at low level, A is at high level, A has increased, B has also increased, right. Yeah, that is what I said. A is at a level, lower level, A is at a high level. So, A is at a low level, A is at a high level, B is at a low level, okay, B is at a low level, B low and B high, right. You mark A1, A2 is what? A low, A high, B low, B high, clear. Is there any questions here? A low, A high, B low, B high. A1 is nothing but A low. So, A low, B low is this point. Now, what do you expect? A high, B high should be higher. If it does just a linear change, A high, B high should be where? Higher, okay. And what is this one? What is this one? B1 is B low. So, let us instead of B, I will write it as A positive low, that way it is easy. This is A negative, A positive, B negative. So, this is B1 is B negative, B2 is B positive. See, the two factors are A and B are the two factors, okay. A and B are two factors, A1 is A negative, A2 is A positive, B1 is negative, B2 is B positive. What is B positive? Is the B at high level, B negative is B at low level, A1 is A negative is A at low level, A positive is A at high level. So, there are 4 data points here, right. In this graph, how many data points you have? In this graph, how many data points have? You have, what is this data point? This data point is A negative, B negative, okay. This is also A negative, B negative, okay, right. This is the lower, and what is this point? A positive, B positive, huh? No, I have written this is the outcome when I have, so that is what I wrote, this is a B2 value, okay. So, okay, let us have, okay, this is blue color is, so this is A negative, B negative, okay. There are 4 data points, this is A positive, B negative. What is this? A negative, okay, the red color is B positive and blue is B negative and the levels are indicated here, okay. So, these are my 4 data points. Everybody clear about the 4 data points? A negative, B negative, A positive, B negative, and what is the second one? A negative, B positive, A positive, B positive. Now, look at this, is there an interaction is the question. Just look at this data and tell me, is there an interaction or not? How do you quantify interaction? How do you say whether there is an interaction or not? Just look at this, how do you say whether there is an interaction, significant interaction or there not, how do you say? What, how do you, I mean, you understand my question? You have 2 factors, I do not want individual effects, I want whether there is an interaction or not. How do you do that? Think about it, how do you do that? Huh? Slope of what? Good, slope of what? There are 4 cases, A negative, B negative, all possible combinations are represented here. A negative, B negative, A negative, B positive, A positive, B negative, A positive, B positive. 4 data points are there. What slope are you finding? To understand, so let us say if I want to understand effect of A, how do I do this? In this simple 2 cross 2, if I want to understand effect of A, how do I do? If you think about that, then naturally it will be easy. No, just to think of, don't bring in math we will commit late. Just tell me in layman, I want to understand effect of A. What is the effect of A here? What is the effect of A? Keep B. So how do I do it? Tell me. A positive, B negative plus A positive, B positive divided by 2 minus A negative, B positive plus A negative, B negative. Does it make sense? Does this make sense? This is my effect of, is there everybody clear? Common man, common sense. Effect of A, difference in A at 2 levels. You want to see the difference of A at 2 levels, that is what effect of A is, irrespective of B. It is irrespective of the other factors. So what I should do? I kept A both positive irrespective of B, I took an average, and then A at low level I averaged it for B, 2 levels of B, then I take the difference. This is main effect of A. What is main effect of B here? How do I write effect of B? A negative, B positive plus A positive, B positive divided by 2 minus A negative, B negative. So sorry, this should be, okay, this is wrong. A positive, B negative. I am looking at the effect of A, right? I am looking at the effect of A, right. Now A negative, B negative plus A positive, B negative divided by 2, right. This is my effect of B. Please pay attention, if you are not able to follow me, let me know. Is this making sense? No? Not making sense. So you look at how do I, what is effect of A? Positive A minus negative A. It should be irrespective of the other factor B. Then you take A positive for all combinations of B, average it out, because you are doing 2 they are there, so you average it out. Similarly for negative of A, average it out, then difference it. That is what effect of A is. Effect of AB, how do I write? How do I write effect of AB here? Both plus minus. So A positive, B positive minus A negative, B negative divided by, that is what interaction is. Does it make sense? This is a decent estimate of the interaction. Clear? So this idea should be clear, right? What is effect of A, effect of B? Effect of A is A irrespective of B, okay, A irrespective of B, and effect of B is A irrespective, B irrespective of A, you can average it out. And this is my interaction, A plus B plus minus A negative, B negative divided by 2. This is what is interaction. So now looking at the data only, you should be able to say whether there is an interaction or not. Okay. If I take minus 80 is A negative, A positive, B positive. A negative is what? 5. A negative, B negative is 5. So minus 80 minus 85 divided by 2, which is a big number, minus 42.5, which is a big number. Okay. So, just by plotting also you should be able to see the interactions. If there were no interactions, how would this graph look like? It should have, the point should have shifted upwards, because A positive, B positive minus A negative, B negative by 2 is what the interaction is. Now since this point is here, when you subtract it, I mean it gets, the interaction becomes significant here, and the worst is here. This is the worst case, a lot of interaction. This is a negative interaction, right? Here you have negative interaction, right? What you would have expected, A positive B, if A positive, you see this is what is this? This is A positive B negative is high, A positive B negative is higher than A positive B positive. What does it tell you? It is actually one is pulling the effect of the other. Just by doing simple graph, plotting a simple graph, you should be able to say, look at the second graph, that this point, what is this point? A2 B1, that is nothing but A positive B negative, and what is this? This is A positive B positive. See, A positive B positive is lower than A negative, A positive B negative. What does it mean? The influence of B is inhibiting the influence of A, or they are going in opposite directions. The interaction is negative, there is no synergy, it is opposite, one is inhibiting the other, right? Just by plotting you should be able to say. Whereas in this case, again what do you see? One is inhibiting the other. This is again a case where A positive B negative is greater than A positive B positive. That means what? You could have just used treatment A to influence the output significantly rather than combining with treatment B, because when you combine, the output is on the lower side. Okay. So this is, both are inhibition cases, the second graph is even worse, but this is where interactions happen. And you could have a positive interaction. If you have a positive interaction, what it should be? If I have a positive interaction, how should it be? I could have something like this, very high. A alone is not nothing, but this is significantly diverged. So I could have something like this. This is A negative B negative, right? So if I have A negative B negative, I could have this graph going like diverging like this very highly. This will be a positive interaction because the combined effect. So the slope of A plus B plus minus, that is when I said slope, what is the slope I was asking? The slope of A positive B positive A negative B negative line, if that is high positive, then you have a positive interaction. That is negative and significantly negative, then you have a negative interaction. You are just seeing the slope of A positive B positive minus A negative B negative. What is this? This is 9 as x2 minus x1, right? What is slope y2 minus y1 by x2 minus x1? So that is what you are in a sense taking. What is the rate of change of A positive B positive and A negative B negative line? Okay, that will tell me whether there is a significant positive interaction or negative interaction. Make sense everybody? Just with the simple graph you should be tell. Okay. So the design on the previous slide, whatever we have shown here is a 2 cross 2, the simplest possible factorial design. Okay. As I said factorials because you are talking about combinations and doing interactions. You are looking at the crossed combinations, all combinations. Okay. We frequently use on 3 and 4 variables, but beware, it is very difficult to interact and interpret an interaction among 4 variables unless you do it numerically. Graphically it becomes so complicated to look at interactions for 4 variables or 3 variables, it will become complicated. So you have to come up with a numerical way to understand